Hello viewers, in today's session we are going to discuss a very interesting problem from integrals, and here we have to evaluate this integral that is from 0 to 1 x raised to 6, and here we have 1 minus x raised to 4 raised to 1 by 4 dx. So here we'll evaluate this integral with the help of the concept of beta and gamma functions, right? So before solving this integral, let us quickly see the results which we are going to use while solving this integral. So here we'll first use the definition of a beta function, that is beta m comma n is given by 0 to 1, and we have t raised to m minus 1, 1 minus t raised to n minus 1 dt, where m and n are greater than 0, right? So this is the definition of beta function. So beta m comma n is given by this integral where m and n are positive numbers, right? And the second result is the relationship between beta function and gamma function, that is beta m comma n is given by gamma m times gamma n divided by gamma of m plus n, right? And the third result is the famous Euler's reflection formula, that is gamma n times gamma of 1 minus n is given by pi divided by sine n pi, right? And the another result is gamma of n plus 1 is given by n factorial, where n is some whole number, right? And similarly here we have another relation, that is gamma n plus 1 is given by n times gamma of n, right? So here we have these 5 results which are helpful in evaluating this integral. So apart from these 5 results, we'll make use of the method of substitution. So let us call this integral as I, and let us make this substitution, that is t is equal to x raised to 4. So we have x is equal to t raised to 1 over 4. Now let us differentiate x with respect to t. So we have dx over dt, that is d by dt of t raised to 1 by 4. And here we will make use of the power rule. So we have 1 over 4 t raised to 1 by 4 minus 1. So we have 1 over 4 t raised to minus 3 by 4. So now dx is equal to 1 by 4 t raised to minus 3 by 4 dt, and dt. So the value of dx is given by this expression, right? Now see here, the limits of integration vary from 0 to 1. So when x is equal to 0, then the value of t is it can be obtained from this expression. So taking x is equal to 0, we have 0 raised to 4, that is 0. And when x is equal to 1, then we have t is equal to 1 raised to 4, that is 1. So when x varies from 0 to 1, t varies from 0 to 1. So now let us express this integral in terms of the variable t. So we have I, and the limits remains the same, 0 to 1. For x we can write t raised to 1 by 4 to the power 6, and then we have 1 minus t for x raised to 4, and here we have 1 by 4, and for dx we can write 1 by 4 t raised to minus 3 by 4 dt. Now we can take 1 by 4 outside the integral. We have 0 to 1, and here we have t raised to 6 by 4, and here we have t raised to minus 3 by 4. So by the laws of exponents, so we can add these two exponents because base are same. So here we have minus 3 by 4, and here 1 minus t raised to 1 by 4 dt. So now we have 1 by 4, 0 to 1, t raised to this is 6 by 4 minus 3 by 4, that is 6 minus 3 by 4, that is 3 by 4. So here we have 3 by 4, 1 minus t raised to 1 by 4 dt, right? So now we can see that this integral is similar to this one, except the powers should be expressed as m minus 1 and n minus 1. So here we have 3 by 4, so m minus 1 can be written as 3 by 4, so m is 3 by 4 plus 1, that is 3 plus 4 over 4, that is 7 by 4, right? And here we have 1 by 4, here we have n minus 1, so n minus 1 is equal to 1 by 4, so n is 1 by 4 plus 1, that is 1 plus 4 over 4, that is 5 by 4, right? So now we can write this integral I as 1 by 4, 0 to 1, and t raised to 3 by 4 can be written as m minus 1, and m is 7 by 4. So here we have 7 by 4 minus 1, then we have 1 minus t raised to 1 by 4. 1 by 4 can be written as n minus 1, n is 5 by 4, and here we have minus 1, and here we have dt. So now this integral assumes this form where m is 7 by 4 and n is 5 by 4. So we have I is equal to 1 by 4 times the beta function, that is m comma n, and m is given by 7 by 4 and n is 5 by 4. So now to evaluate the value of this beta function, we have to make use of this result. So we have I 1 by 4, then we have gamma of m, that is gamma of 7 by 4, then gamma of 5 by 4 divided by gamma of 7 by 4 plus 5 by 4, right? Now we can write 1 by 4. Now see, we can find out the value of gamma of 7 by 4 as we can write 7 by 4 as 3 by 4 plus 1, and we can make use of this result, that is n is 3 by 4, right? And we can have 3 by 4 plus 1 of gamma, so we have here 3 by 4 gamma of 3 by 4, and similarly we can find out gamma of 5 by 4. Again, making use of this result, we can write 5 by 4 as 1 by 4 plus 1. So in this case the value of n is 1 by 4, so we have 1 by 4, then gamma of 1 by 4. So here we can now write 3 by 4 gamma of 3 by 4, and here we have 1 by 4 gamma of 1 by 4, and in the denominator we have gamma of 7 by 4 plus 5 by 4. So this is 7 plus 5 by 4. So this is gamma of 12 by 4. This is gamma of 3. And gamma of 3 can be written as 2 plus 1. And using this result, we can write gamma of n plus 1 as n factorial. So n is 2. So here we have 2 factorial. That is 2 times 1. That is equal to 2. So here we can write 2. So now we have I is equal to 1 by 4. We have 3 by 4. Here we have 1 by 4. and here we have half, so we can write 1 by 2, and we have these two terms, so we can write gamma of 1 by 4 and gamma of 3 by 4. So this is we can multiply these four fractions, so we have 3, and here we have 4 times 4 16 times 4 64 times 2 128, right? And here we have gamma of 1 by 4, and gamma of 3 by 4 can be written as gamma 1 minus 1 by 4, and we can now see that this is of this form, that is gamma of n times gamma of 1 minus n. So the value of n is 1 by 4. So using Euler's reflection formula, we have now 3 by 128, and here we have pi divided by sine n pi. So n is 1 by 4, and here we have pi. Now this is sine pi by 4, and sine pi by 4 is sine 45 degrees, that is 1 over square root of 2. So now we have 3 over 128 pi divided by 1 over square root of 2. So taking square root of 2 to the numerator, we have 3 over 128 times pi root 2 over 1. So this is 3 pi square root of 2 over 128. So viewers, the value of this integral I is given by 3 pi root 2 divided by 128. So this is how, by the method of beta and gamma functions and utilizing all these important results, we can evaluate these kind of integrals.